Okay. So now, can we apply this method, for example? Let's take the following example. And I'm solving y double prime minus y equal e to the x. So using the table above, it seems that a e to the x should think about particular solution of the form a e to the x. But will this work? It wouldn't work. Why? Because what is L of e to the x? L of e to the x is e to the x double prime minus e to the x equal e to the x minus e to the x equal to 0. So L of a e to the x equal to 0. And our choice will fail. There's no particular solution of the form a to the x. Now, why is this? This is because, why is this? Since e to the x is a solution to the homogeneous equation. Do you agree? i.e., m equal 1 is a root to m equal 1 is a root to the auxiliary equation. Then this is, then I don't expect e to the x to work. What about if I try L of x e to the x? So if I try L of x e to the x, so this is equal x e to the x prime minus x e to the x. So in this case, what is x e to the x prime? Is x e to the x plus e to the x minus x e to the x, and this is equal e to the x. So when I apply L to the operator L to the function x e to the x, I got e to the x. So this implies that y particular equal x e to the x. So here I have to multiply by x to get. So this is the case of redundancy. So this is what we're going to investigate. So the question is, what if I want to solve L of y equal e to the alpha x with alpha a root to the auxiliary, to the corresponding auxiliary equation. Not also only e to the alpha x, I can replace e to the alpha x by a polynomial with a polynomial of degree k with x, or e to the alpha x with cosine beta x, and all these cases. But let's talk about this first, okay? So let's start with an example. Let's solve y double prime minus 5y prime plus 4y equal e to the 4x. Now step 1. Okay, this is called case of redundancy. So this is called redundancy. What if I have redundancy between my table of particular solution and my homogeneous solution? So step 1. So I solve y double prime minus 5y prime plus 4y equal to 0. So the auxiliary, so y equal e to the mx solves the ODE if and only if, so the solve L of y equals 0 if and only if m is a solution to the auxiliary equation m squared minus 5m plus 4 equal to 0. So I want two numbers whose product is 4 and sum is 5. So this is m plus 1 times m is m minus 1 times m minus 4. So they are 1 and 4 equal to 0. So this implies that y c is c1 e to the x plus c2 e to the 4x. So you notice that e to the 4x, that m equal 4, so m equal 1, m equal 4, are real simple roots. Now step 2, particular solution. So I know that a e to the 4x will not work due to redundancy. Then I try a x e to the 4x like I did above. So let's try this. So L of x e to the 4x equal x e to the 4x double prime minus 5 x e to the 4x prime plus 4x e to the 4x. So let's see, what is x e to the 4x prime? This is equal to 4x e to the 4x plus e to the 4x. What about x e to the 4x double prime? I have to differentiate this again. So I get 16x e to the 4x plus 4 e to the 4x plus 4 e to the 4x. Then I get L of x e to the 4x. This is equal, if you do double prime, so I combine, I have 16 x e to the 4x plus 8 e to the 4x. You will see I will always write this, under each other, okay? It's not because I don't have space, but I will have to write them like this so that to see. And here I have 4x e to the 4x plus e to the 4x minus 5y prime, and I have plus 4y plus 4 x e to the 4x. Now notice 16 minus 20 plus 4, the x e to the 4x will cancel. I have one lower degree. So we have start with x e to the 4x. I will go to, this is a polynomial of degree 1 times e to the 4x. I got a constant times e to the 4x. So what do I get here? 8 minus 5 is 3. 3 plus 4 is 7. Yes. So let's see. So I have 8 minus 4. Oh, that's just 8 minus 4. Here I don't have x. E to the 4x, and this is equal 8 minus 5. 3 e to the 4x. Then what is L of a x e to the 4x? This will be a L of x e to the 4x, and this is equal 3a e to the 4x, and I want 3a e to the 4x to be equal to e to the 4x, because this was the right hand side, so a is equal 1 over 3. And then you get that your particular solution is 1/3 e to the, well, 1/3 x e to the 4x. And conclusion, I have y equal yc plus yp, where yc is c1 e to the 4x plus c2 e to the x plus 1/3 x e to the 4x. Okay. What if I had, so another example, what if I had y double prime minus 5y prime plus 4y equal x e to the x? Okay. So using the table, you would think that a particular solution yp will be ax e to the x plus b e to the x, a combination of these two things. But I know that L of e to the x, this is the same ODE, so what is yc? Is c1 e to the x plus c2 e to the 4x. Okay? So e to the x is already a solution, so I have redundancy. You see, this is in my particular solution, and this is also a homogeneous solution. So L of e to the x is equal to 0. So this will not work. In fact, try L of x e to the 4x, L of x e to the x, try it. You will get one smaller degree, it's a polynomial of degree 1 times e to the x, you will get minus 3 e to the x. And what is L of e to the x? Equal to 0. So L of a x e to the x plus b e to the x, this is equal to something, to some constant, times e to the x, and not x, and will never get x e to the x. So how do I get rid of the redundancy? I multiply by x and calculate. So this term will not play a role, okay? And this term will give me e to the x, so it will not work. So I multiply by x and compute L of x squared e to the x. And now do it also, you get, this is an exercise, you get minus 6x e to the x plus 2 e to the x. But I only want x times e to the x, okay? So how do I get rid of this? I try yp to be a x squared e to the x, which will give me this. What will give me a constant times e to the x plus b x e to the x, okay? So it's as if I multiply the choice of the table by x due to redundancy. And then solving this, then L of yp is equal a L of x squared e to the x plus b L of x e to the x. And then you get this is a times minus 6x e to the x plus 2 e to the x plus b into e to the minus 3 e to the x. And this implies, so, and I want this to be equal, so I want this to be equal to x e to the x. So this means minus 6a equal 1 and 2a minus 3b equals 0. And this implies a equal 1 over 6 and b equal minus 1 over 9. And then you get that yp equal minus 1 over 6 x squared e to the x minus 1 over 9 x e to the x. And the solution is c1 e to the x plus c2 e to the 4x minus 1 over 6 x squared e to the x minus 1 over 9 x e to the x. So you see, when you start with x squared e to the x, so when you start with x squared e to the x and you apply L, you get a constant times x e to the x. So you get like something like degree 1 times e to the x. Why? Because e to the x is a solution. Okay. Now if you start with x cubed e to the x, you will get degree 2 times e to the x. Well, if you start with xr e to the x, you will get degree r minus 1 times e to the x. Okay. Same if you have L of xr e to the 4x, because 4 is a solution, you will get degree r minus 1 times e to the 4x. But what if I start with L of xr e to the 5x? Now 5 is not a solution, so you will get degree r times e to the 5x. The degree will stay the same. Okay. Now in general, if m is a solution of order of multiplicity k, then L of x power r e to the mx, it will be x power r minus k e to the mx. So in order to remove the in order to remove the redundancy, you have to multiply it by xk times, which is a multiplicity. Okay? So the theorem, well, this is a theorem. Well, this is for r larger than k, of course. Because for r smaller than k, and for r smaller than k, L of xr e to the mx is equal to 0. Because you have m is a solution of order k of m is a root of multiplicity k, then 1 x e to the mx, then e to the mx, x e to the mx, x squared e to the mx, x up to x power k minus 1 e to the mx are solution. Okay. Now, so also if p of x is a polynomial of degree r with r larger than k, and m is a root of multiplicity k, then L of p of x e to the mx is equal L of p of x e to the mx is equal to what? Is equal degree r degree so m is a multiplicity p of x, okay, r larger than k, so degree r, like here, degree r minus k times e to the mx. So should try yp to be a polynomial of degree r plus k e to the mx. Okay. So if I have a root of multiplicity 5, I go to the table and I see e to the 5x is a solution, for example. And 5 is a root of polynomial of multiplicity 2, or let's say 5 is a root of multiplicity 3. Then I don't try e to the 5x. I don't try x e to the 5x. I don't try x squared e to the 5x. Multiplicity 3, I try x cubed e to the 5x. Okay, so let's do a couple of examples. So example, let's try to solve y triple prime minus 3y prime plus 2y equal 4 e to the x plus 6 e to the minus 2x. Okay, then solution. Step 1, homogeneous solution. I have m cubed minus 3m plus 2 equal to 0. Okay. So this is the auxiliary equation. I'm being fast here. Then how do I find a root here? I look at 2. What are the root? Plus or minus 1, the divisor, plus or minus 2. Try 1, you get m minus 1. Okay. Now m minus 1, m should be multiplied by something to get m cubed, m squared. Minus 1 should be multiplied by what to get plus 2, minus 2. And if you try things here, I want bm equals 0. But what is the coefficient of m squared here? It is 0. What's the coefficient of m squared here? It is b minus 1. So b will be equal to 1. So this is m minus 1 into m squared plus m minus 2 equals 0. So this is m minus 1. I want two numbers whose sum is minus 1 and product is minus 2. So this is m plus 1, well, you want the product is minus 2 and the sum is 1. So this is m plus 2, m minus 1 equal to 0. So this is m minus 1 squared into m plus 2 equal to 0. So m equal 1 is a root of multiplicity 2, which give me two solution y1 equal e to the x, y2 equal x e to the x. What about m equal minus 2 is a root of multiplicity 1, which give me y3 equal e to the minus 2x, then yc equals c1 e to the x plus c2x e to the x plus c3 e to the minus 2x. Now it's in trouble here because here I have e to the x, here I have e to the minus 2x. So step 2, we find a particular solution to L of yp to L of y equal 4e to, so find particular yp1, 4e to the x. Now in the table, I have yp is what? Is a e to the x. But e to the x appear in the solution. It's, I mean, 1 is a root of multiplicity 2, which means I have to multiply this by x squared. So this is a x squared e to the x. Or how do you think about it? You see e to the x. It's in my table, okay? But e to the x, that's what I multiply by x. Does I still have redundancy? Yes, because x e to the x is also a solution. I'll multiply by x again, and then I get x squared e to the x is a solution. Okay. Then now I calculate L of x squared e to the x. So what is what is x e to the x squared e to the x prime? This is equal to x squared e to the x plus 2x e to the x. What is x squared e to the x double prime? This is x squared e to the x plus 4x e to the x plus 2 e to the x. Then what is L of x squared e to the x? I still have triple prime. X squared e to the x triple prime. This is x squared e to the x plus 2x plus 4x plus 6x e to the x plus 6 e to the x. So what is L of x squared e to the x? I start y triple prime. So it's x squared e to the x plus 6x e to the x plus 6 e to the x. Plus, what is L of, well, then I have y prime minus 3y prime. So minus 3 x squared e to the x plus 2x e to the x. And then plus 2 x squared e to the x. Now notice x squared e to the x squared e to the x, this will cancel with minus 3x e to the x. So this will give me, I also have 6x and 6x, also this will cancel. Because I started with x squared e to the x, and e to the, 1 is a root of multiplicity 2, I should get a constant times the x. I expect the degree to go down by 2. So what do I get is really 6 e to the x. So what is yp? Yp is a x squared e to the x. So I try L of a x squared e to the x. This is equal a L of x squared e to the x. And this is equal to 6a e to the x. And I want L of yp to be equal 4 e to the x, and this implies a equal to third. So what is yp1? Yp1 equal to third e to the x squared e to the x. Now, so step 3, I need to solve y triple prime, so find yp2 to y triple prime minus 3y prime plus 2y equal x plus 6 e to the minus 2x. now I have that m equal minus 2 is a, well, the table gives me y equal ax plus b e to the minus 2x. But now m equal minus 2 is a root of multiplicity 1. So because I have e to the minus 2x is a solution. So this will not work. B e to the minus 2x will give me 0. So this will not work. So I multiply this by x power the multiplicity, which is x power 1. So I try yp2 equal ax squared plus bx e to the minus 2x. Okay. And then do this. Let me do it. I should do it at least one. So this is yp2, and then I start. What is, so this is equal ax squared e to the minus 2x plus bx e to the minus 2x. Okay, you can check that L of x squared e to the L of x, yes, L of x squared e to the minus 2x, do this is 18x e to the minus 2x minus 12 e to the minus 2x. What about L of x e to the minus 2x? This is equal minus 12 e to the minus 2x. So what is L of yp2? It's a L of x squared e to the minus 2x plus b L of x e to the minus 2x. And this will be equal a times 18x e to the minus 2x minus 12 e to the minus 2x plus b into minus 12 e to the minus 2x. And this is equal 18a x e to the minus 2x minus 24 . So L of x, this is equal, let's change the color. This is equal 9. So this is 9. Okay. So minus, okay, so you get 18a x e to the minus 2x plus minus 12a minus 9 plus 9b e to the minus 2x, and I want this to be equal x plus 6 e to the minus 2x. So this is what I want, which is equal x e to the minus 2x plus 6 e to the minus 2x, which means I want 18a to be equal to 1 and minus 12a plus 9b to be equal to 6. And this implies a equal 1 over 18 and b equal 20 over 27. Then you get yp2 equal 20 over 1 over 18 x squared e to the 2x plus 20 over 27 x e to the minus 2x. So what will be y? It will be yc plus yp equals c1 e to the x plus c2x e to the x plus c3 e to the minus 2x plus 2 over 3 x squared e to the x plus 20 over 27 x e to the minus 2x plus 1 over 18 x squared e to the minus 2x. Just let me check e to the x is correct. Yes. And that's it. Okay. One last example. Find the form, and you calculate at home, of the particular solution. So I have y double prime plus y equals sine 2x plus sine x. Okay. Then first, step 1, I solve y double prime plus y equal to 0. I need to know this. And then you get y homogeneous is c1 cosine x plus c2 sine x. So step 2, so this is like saying e to the ix is a solution. Remember the complex solution. So step 2, what about sine e to the plus or minus ix? Yes. What about, so find yp1 solution to y double prime plus y equals sine 2x. And remember, sine 2x is 2ix minus e to the minus 2ix over 2I. But 2I it's not work. I mean, here m equal I plus or minus I. Here I have 2I, so I don't have redundancy. So I use what I have known in the table. This is a sine 2x plus b cosine 2x. So this is yp1. Step 3, find yp2 solution to y double prime plus y equals sine x. Now the table tells me yp2 is a sine x plus b cosine x. But sine x is e to the ix plus minus e to the minus ix over 2I. So I have sine x. By the way, I have sine x as a solution, as a homogeneous solution. So the sine x will not work. The cosine x will not work. And this is a repeated solution once. I only have sine x. I don't have x sine x. So I multiply by x. Do I still have redundancy? No, because x sine x nor x cosine x is a solution. And this will be your yp2. So your y will be c1 cosine x plus c2 sine x plus a sine 2x plus b cosine 2x. So find a and b. Find a, b. Maybe here I should write c, d. Find c and d. Plus cx sine x plus dx cosine x. And this is an exercise, okay? You should get y equals c1 cosine x plus c2 sine x minus 1/3 sine 2x minus 1/2 x cosine x. Thank you.